my experience kind of ties directly into IR 4.0. I've been in the embedded software industry for most of those 40 years. I was also working with mobile. I'm actually one of those people you hear about that was a rocket scientist. I actually worked on the space shuttle and things like that. But really, I'm a snow skier. So that's one of my other main passions. But we won't talk a lot about that. But we are putting smart things in. I have a ski jacket that's a smart ski jacket. We put smart intelligence in everything now. I do live in the United States, actually, Rocky Mountains of Colorado, and the picture of my house down there at the bottom. It's a smart solar house. It's a green smart solar house. We've learned a lot with, I'll call it smart things because of that house. And my biggest passion, I think, really is helping people grow and learn. So I'm happy to be invited to speak here. And electrical and electronics 4.0 landscape is kind of shown here. You have everything from smart cities on the top left there to smart factories and smart production to medical devices. I've talked with medical device companies that are now doing connected devices that are connected to the internet. You also have the smart watches and smartphone type of thing as part of that. Up there at the top right, you see a smart car. That's actually a car in the United States, in the mountains where I live. It's a car under test. If you look very, very closely at that picture, it's covered in drapes. We don't know what the car really looks like. It's under test by whatever company. There's 2 or 3 companies in Colorado that run test tracks in the mountains of Colorado. Why? Because the mountains of Colorado are very high, very cold, very snowy, very bumpy, very bad. And so they bring their cars up there to test them. That's actually a test vehicle that you're looking at right there. We know the roads they travel on because they travel the same circuits several times a week. And being a software tester, anytime I find somebody testing something, I'm curious to see what they're doing on that. The big common thing that IR 4.0 has, at least in my mind, one of the driving things of the seemingly unrelated items is data. They're all producing data in massive amounts of data. They're all connected, and we're connecting things more and more. And that really changes a lot of the engineering that I think we have to do on that. So now going forward. Oh, there it goes. This is the Gartner, they call it the hype cycle of things. This is available out on the internet. It changes, they update it every year or so. I think this was last year's one. They'll come out with another one this year. And they kind of survey the industry of things that are coming along and receiving a lot of press and a lot of interest. I'm not going to read all of those, but if you look, a lot of the things that are of immediate interest, development, research and development kinds of things relate to Industry Revolution 4.0 one way or another. And the way the curve works is some of them that are very early on the left side of the curve there, they're very immature. Ones that are at the top, they're getting a lot of press, but they're also immature. And as you move to the right on the chart, things become more mature and in many cases profitable. An awful lot of things evolve out of that. And you'll see a lot of the things that maybe some of you are interested in on that curve, I do believe. But being a tester, first and foremost, as I look at things like IoT and smart factories and robots and those things, I come along and go, are they really working? Are there problems in there? What information do we need to provide to management and customers, but also sometimes to the general public. And this is some actual data from an embedded software system that I used to work on, and it's been published, so I can show it. And kind of what you want to get from that chart is that an awful lot of errors were found during the initial development. And I think IR 4.0, we're going to see a lot of development, a lot of analysis, a lot of problems being found. But you also notice that was only about 70%. 30% were found after the systems went into production, into use on this particular one. And that kind of number might vary a little bit, but what it tells me is that as we develop these systems, as we move to, I'll call it smart cities and smart factories, the development, the research, and for me, being a tester, the testing and quality assurance is going to continue. It can't just be done up front. 30% were found later in the life cycle, which really means that those of you doing these things have to think both the near term, but then what are you doing a few years down the road? What kinds of issues are you going to have to be continuing to, I'll say, find and information provide about this particular set are errors. And this was a fairly small embedded system, by the way. This wasn't as big as the ones we're doing now. So what I want to do for the rest of this, how much time do I have? Yeah, I don't know, 30 minutes plus minus, something like that. I want to give you some of the areas that are, I'll call it challenges. I really look at challenges as an opportunity, something where somebody can get in there, come up with some good ideas, do some good things. Some people call them challenges, some people call them risks. I call them opportunities, where people can do some work. And these certainly aren't all the ones that I can think of, but these are my current top ones that I personally look at, research, and read on. And so I'm going to talk through each one of these. There's hardware and software that's very specialized. There's the integration. There's lots of third-party functionality. I'll talk more about each one of these. And then this issue of massive amounts of data. And then the final one that probably should be top on the list, but I always put it at the end, is security and privacy. Those are big ones for many of us as we move into this IR 4.0. And there's certainly others, but those are my current ones. So I want to step through each one of these. Specialized hardware, specialized software. So many people in the tech industry just think software, web systems and generic computer boxes and things like that. But really, IR 4.0 in my mind is about the blending of hardware, systems, and software together into complex networks, complex systems, smart cities, smart factories. And so we can no longer just think the software. And yes, I was a software person, but being in an embedded space, we were what's also called cyber-physical systems, meaning the systems interact with the real world and many times affect the real world. You see it now in smart cars and smart airplanes, and everything's smart, right? And so this notion of cyber-physical systems requires some change in thinking of many of our software people, maybe even some of our hardware people. The place I came out of, we were always cyber-physical systems. We were always embedded. We always had sensors and large amounts of data. I used to think we had large amounts of data. Some of the systems I worked on, we would generate 1 to 4 terabytes of data during the test cycle. I've recently gone to a few places like Airbus and some other companies. They will generate 4 to 8 terabytes of data during a single test cycle. I don't know if you know how much data that is, but humans can't process that much data. It changes how we do things. They also control things in the real world. If you think about smart cars or a smart city, we're controlling things that are physical. It isn't just the software anymore on somebody's computer screen on the web when you're trying to buy something. It's literally changing the physical world. Then there's this issue of communications. The little smartphones that you're all carrying and things like that, and the networks, those enabled a lot of this. We didn't used to have that. First computer I had a network connection, but it was an acoustic modem that went over the phone lines at 300 baud. That was as good as it got back in the 70s for personal computers. Now people go, what's an acoustic modem? What's a dial phone? We have these phones that talk to us so we can talk to them. The communication has changed with all of this. And then the big one in that is the real world interaction of these things. And they're all tied together. And they're all generating this massive amount of data. So the kinds of things that I think you have to think about to address that a lot of us have been working on in cyber-physical systems, and as they evolve into 4.0, is the need for modeling and device/data management. You have to control those massive amounts of data. You have to know where they are, where they're going, where they're being used. We have to address changing life cycles. Those are things both like Agile and the DevOps, but also the analytics of all those things. How do we analyze 8 terabytes worth of data that are coming in real time? Humans can't do it. You have to start looking at things like data analytics, data science, and now artificial intelligence. And I've worked with AI also in my career. 20 years ago when I first started using it, wasn't right the time because we didn't have enough data to program the neural networks, as an example, and also we didn't have the compute power. I've heard people estimate that right now, today, for the typical AI system, even at places like Microsoft and Google, they're about the equivalent of a mouse in terms of the amount of connections and the amount of data that's being processed. Not even close to a human. The projection is that stuff's going to grow to like human size somewhere maybe 5 to 10 years out. And we're going to have to understand how to manage that and deal with that. And the UML, the SysML, and the area I worked on was called UML testing profile. Those are industry standards that people are going to have to learn and do and then interface with. So if I'm producing a smart factory that maybe has to produce something for a smart city, I'm going to do some of that with models, and those models have to talk with each other. That's what use of those modeling standards can help with. So there's something out there called digital twinning in some of this, and that's where you have, as I was saying, maybe a model for the factory and a model for the smart city, and the two models have to talk with each other. We also have to have the static and dynamic representations of these models. And this is not simple stuff. The modeling places I worked with, it took a lot of time to get the models going up and working. And finally comes the interfaces and the interconnects. Where we were doing some of this in the cyber-physical world, we were doing development with models. This last system I was on, for the first time ever, the developers, software developers, were doing modeling. I asked them, I said, is it hard to do the models and generate the code out of the model? They said yes. But where the payoff for them was, because they were a big team working with hardware people, the payoff was at the integration level, because the models were interconnected inside of the cyberspace, and if I changed something in one place that affected the engineer in another place, the model informed the engineers of that. And they didn't have to wait until they were actually integrating the two systems together, or the two software and hardware together to find the problem. And so they thought it was well worth the extra effort. Next one, challenge, is this integration problem. We've seen in places I worked, things do not integrate well. And we spent a lot of time working integration. In fact, the company I worked with, we actually had a disciplined area inside of the systems engineering called an integration engineer, because it was so hard to integrate big systems and systems of systems and software all together. There were specialized people for the integration cycle. And you start seeing it a little bit here. The square that you're looking at, that's the representation of the size of the number of Android phones. Each little box is an Android phone configuration, if you will. And you'll notice there's a lot of them. Imagine I had to test each one of those configurations to make sure it worked with what it was I was producing. It'd be hard to do. Well, it gets worse. If I throw the Internet of Things in there, where I'm now Android interfaced to my little heart device, I've got to test all that and all those configurations. It gets worse. I might have to test different user interfaces and different communication channels. In my house, we have 3 or 4 communication channels, one to the outside world. We have some problems with that. The vendors of those things go, you're on your own. You're doing weird things. Yes, we're engineers, so we do weird things. But really, I shouldn't have to make those phone calls to people. You have IoT protocols. You have different stakeholder data streams. And as a little example, if you add all those things up, multiply them up, it's known as the combinatorial problem, all the combinations. I have to do 65,000 tests. No tester, no team wants to run 65,000 tests. It's just, it's not going to be feasible time-wise and economically. But there's something out there that I've helped research, and I've been into big companies talking to them about this. I was surprised, actually. You would think really big companies have really smart engineers that know all this stuff. I won't name them, but it was one of the 2 big aircraft manufacturers in the world. So you can guess probably which 2, one of the ones I was talking with. And I'm talking to their senior engineers, and they're in a really cool facility, by the way. But I said, you have this problem of all these parts. And they went, yes. So there's something called combinatorial testing out there that some of the research institutes, particularly in the US, have been doing. You can take that 65,000 tests and get it down to about 120 tests. That's doable. And the error finding ability of those 120 tests, this has been researched, is about 80%. In other words, you're going to find 80% of those kind of errors that if you ran all 65,000 tests. That's a pretty good ratio. If I'm dropping to 120 but finding 80% of the issues, I'll take that kind of thing. And you don't need to show all those little things. Those are how the tools are set up and thinking through that. That's a good savings as one example of how to deal with this integration issue and this explosion of configurations that are going to be out there in cyber-physical IR 4.0. The next one that I see and personally experienced is the various kinds of commercial hardware, commercial software, open source software. A lot of the engineers I work with now, they're trained in school. You use microservices, and you don't create a lot of code. You create some glue code. You go get some parts from open source. You get some vendor software. You get some vendor off-the-shelf hardware. You glue the thing together, and you got your system, which is true. That can work. But it comes with some issues, at least in my mind. One of the things we know is that some of the third-party open source software and even commercial software sometimes is infected with viruses and things like that. I'll talk more about security in a moment, but that's one of the concerns. Also, you don't know sometimes the configuration and pedigree and how well it's been assessed and tested. That kind of means that when you're building one of these IR 4.0 systems, maybe a factory, and you're putting all these things in, somebody has to take responsibility for the assessment of those things. It's usually going to be the prime contractor and maybe some of their main subcontractors that make sure that that factory, or imagine, I was in KL traffic last night, half-hour trip was 2 hours, and I was like, gee, it'd be really nice if the KL's traffic system was a little bit smarter. A lot of the cities are looking at that. Many of the big cities were, in Denver we looked at, we had one little town and they were going to put up smart stoplights, they put up cameras. You would have thought we were trying to kill somebody. I wasn't personally doing, but what the concern was is that they were going to use it to give people traffic tickets, one, and two, that they were monitoring where everybody was going. What they were doing is trying to make the traffic flow better, but people were like freaking out on it. This is the kind of thing that when we do this stuff, we have to be able to address it, tell people the system's safe, the third party's safe, and the system's really for your benefit. You're going to get better traffic. I don't know if what they did with that one. So the piece parts, we need to have like COTS things that are maybe kind of trusted hardware and software. Places I worked, we had trusted vendors. We could not put in certain things, other things we could put in because they've been improved. You have to think of as many things as providing services. So an example might be, I've got my smart stoplights and things, but who's going to do the data analytics? Probably going to be a third-party provider that's doing data analytics or maybe AI analytics. Why? Because the traffic engineers probably aren't AI engineers. The industry needs to be part of that during the operations and development. And I really like to call it DevOps and test. Why? Because I see testing as being continuous out there. And there's a saying that I've kind of modified from a Russian leader that it's tempting to trust these other vendors, but you really need to verify and evaluate as a must. And I like to use things like standards, and I think AI and statistics on those kinds of things. So standards, I mentioned that. People tend not to like standards, and I kind of get why. They can be kind of confining and things like that. And yes, I work on standards, so maybe I have a little vested interest. But like ISO 29119 that Dr. Nishi and I and Amir and Mistura have all worked on, it's a big standard. There's 5 parts, soon to be 6 parts, soon to be maybe 11 parts, addressing everything you can think of and testing. And some of the parts are probably that thick worth of paper. What we try and tell people is those things were not intended to be used as a whole, complete thing. They're intended to be tailored. In fact, that's right up front in the standard. You can evaluate them and get it just to the parts that you need. It serves as a good starting point for many groups, because a lot of people just don't know where to start with that stuff. So it's a collective body of knowledge. I think it'll also help on things that you'll run into with IR 4.0 with legal issues. If you're doing something like a smart city or a smart factory and just kind of trying to wing it, I think there'll be legal ramifications. At least in the US, I know this will be the case. I think it will be the case in Germany if you think what's going on with Volkswagen right at the moment. They're at $33 billion, right? At the moment, they're going to go way over 100 billion US. That's not ringgits, that's US. I would think that they might want to redo what they did years ago in the legal stuff. I think standards of a variety of kinds can help with the integration and interface issues, which I've already talked about. And certainly the testing can be in there. Again, with tailoring on that kind of stuff. I keep pushing the wrong button. The next one, we're going to vary in data. I already mentioned some of the numbers, but there's ways to manage these massive amounts of data. Statistical analysis, data science, and now AI. Now my friends in the AI world, and I dabble with it, they're saying it's 2 to 4 years out on an awful lot of it. Some of it's there now. You probably have noticed when you're on Facebook or Google and things like that, maybe you haven't noticed, if you're doing something and searching on something, and you do the search, and then later on, things will start popping up on your system and your email. That's because the AI systems that Google and Facebook are running are watching you. And I mean that in a nice way, but you need to know that they're watching you and checking on you. And that's part of the data science, okay? And that's the way the world is gonna work. We have to monitor that. EU, probably a little more conservative than some. US, maybe kind of in the middle. I really don't know where Malaysia's at. But we're gonna be buried in this data. We have to have some way to use it. And I think we'll get there using AI and things like that. And here's some of the levels. Petabyte and exabyte I have some knowledge of, but then there's zettabyte and yottabyte. I don't know what those things are. They're like billions of pieces of data. It's very scary stuff. But the user is going to generate that data. We now have the cloud. The cloud grows and grows and grows. We have private clouds and semi-private, and things are going into the cloud. That's where all the data is going. But how to manage it, and then the big question comes for what? Well, I mentioned kind of the sales stuff. That's the current one where they're using a lot of that. They're saying, I can tell what John Hagar wants to buy, so I'm going to, pop an ad up for him, and maybe he'll go to a nice vacation in Malaysia while he's there. We were up in Langkawi. It's very nice. I sunburned my feet. So be careful. But for me, for those of you that are developers and putting new things together, working in the information and 4.0 space, you have to think of this as DevOps and test, particularly the ops and test side. Not the sales side so much, but how do we do this to make better products, better integration? Those are the kinds of things that I believe we need to be looking at. There it is the DevOps test side of things. So, better IR 4.0 data benefits that are out there. I think Malaysia should be looking at this. Delivery, operations, and maintenance, faster cycle times. The big one for me is a happier workforce with more free time. I was telling students this last week, in Japan and China, what is it, 996? Which 9 hours a day for 6 days a week, or something like that. In the US, I'm semi-retired. I like three days a week. And I think that'll make people happier. And if we get some of these tools working in the data analytics, I think we can do where I do all my stuff, I let the system do the data analytics for a day or two, then I come back and I look at it. I think we can have much happier people doing that for the same amount of pay, by the way, but for more productivity at the same time. I think that's possible. Some numbers there you might want to be part of. The increasing of the IR 4.0 around the world, it does say trillion, 4.2 trillion market about 10 years out. That's a lot of money, by the way. That's US dollars again. And it's, push the right button. That data science, that 3 days a week instead of the 996, I think that's achievable, at least by some of us. And here's the data scientist pitch to do that. Oops, push the right buttons. You're going to have to establish a company strategy, works for the board, long-term growth, profit, business models, staffing, capital, those kinds of things. That's the standard business stuff. But the new part's going to be after the plan is in place and we start having an environment and running some things in labs and getting the real data back from the field as part of this DevOps test cycle. And I call it Ms. AI as opposed to Mr. AI. But there's going to be an AI system or systems out there doing this. But the AI systems only go so far. The AI systems still need a human, and that's the person, this data scientist, that goes through the data, understands the data, uses the data, and then goes back to management and says, here's what the data is telling us. Here's what we need to improve. Here's where we maybe need to do a new development cycle or a new piece of hardware, or maybe a better set of stoplights in downtown KL to get out. Because I'm not sure who designed those things, but I think it might have been somebody from England. That's just my guess. I don't know. I'm ex-Scottish and English, so I can pick on them too. But that's what's going to go on. The final one, the scariest one, and I save it for last. Some people say it should be first. The security, privacy, and related with that, safety. these cyber-physical systems, IR 4.0, can kill people, and do kill people. Just look at the recent Boeing grounding of the 737 MAX as a problem of hardware and software. People say it's a software problem, but I'm a little bit familiar with it, having been directly interested in that industry. It's a problem of the system, the software, and the pilot. It was the whole DevOps cycle on that. And again, another company that I'm sure would like to go back and redo some of their engineering on things. And so we all have to learn from that. At least I think we should learn from that. Letting the users be testers as part of the DevOps test cycle, I think I'm okay with that. And a lot of users maybe don't even need to know it. Some do need to know it. But we have to take those data streams coming out of the operations cycle and use it in our engineering and use it in our testers. There are some common programming errors that keep reoccurring over and over. I wrote a book on just this subject. Dr. James Whitaker has written several other books. They're called Patterns of Failure. And we come out with ways to do what are known as software test attacks to go after those patterns of failure. Those patterns of failure will change over time, I'm sure, or I hope. The big data analytics, the AI, will help define where new patterns are at. Don't forget about the hardware, or maybe losing the hardware. And believe it or not, people do lose hardware. I all the time lose my smartphone, but it's really cool. I have a smartwatch, and so I push a button on my smartwatch, and it, as long as I'm inside of about 100 feet or so, my phone rings, which is really good because I'm old and I forget a lot on where. And so, but hardware an issue. Failing the system environment. The Boeing airplane I just mentioned, as I said, the news media says it's a software problem, but it was really a system level problem in my mind that got that. And they've got a lot of work to do. And there's issues on security that the bad guys, we now live in the day and age of black hat hackers. I consider myself a novice white hat hacker, which means I'm a good guy. You're the one, I'm one of the ones you want on your team and things like that. The bad guys are out there too, and they seem to take really perverse pleasure in trying to find the vulnerabilities and the holes in our systems and our software. And so when I had developers years ago telling me nobody would ever do that, my answer now is the bad guys will. They spend months trying to find that one little strange thing that gets them in. And they do get in. And those are the unusual cases. And so from a company standpoint, like here in Malaysia, you need some security test folks, both in your company and probably outside. The big companies in the US, they employ outside people to try and penetrate in. You have to be careful in doing that. I understand Malaysia's got some kind of licensing thing now here also. They do that in the US because you really don't want to go to jail on that. The reason I mention that is last year, a little bit more now, the first use of IoT for a denial of service attack happened. They took over a bunch of devices that were in people's homes and things like that were the IoT type devices, and used that in what's called a denial of service attack. They attacked, I think it was Netflix, Google, and maybe Facebook, and then one other little site. The rumor in the security world was that the one little site was the one the bad guys were really at. They were punishing them for publishing some things. They don't like information about them published. The other big guys, they were just a smoke screen. But the interesting thing was they used IoT devices, things in people's home, through a site called Shodan. If you don't know what the Shodan site is, you might want to go look at it. It lists the IP addresses around the world of many devices that have an IP address, and it shows the ones that are using default passwords. and there's literally millions of people that do not change their passwords. And I've used it a few times in my neighbors, not neighbors, it was my relatives. And I got on there and I said, I can go in and steal your bank account. You want me to do that? They're like, you can do that? I go, yeah, but I'm a nice relative, so I'm not going to do that. But that stuff's out there. You know, we have to think about it in the security world. And so I mentioned this notion of an attack. I like to call it an ethical attack. In other words, the white hat guys doing. The black hat guys are doing the same things and others, but it's a pattern. And these patterns repeat over and over. And it's something that a lot of testers use, but we've kind of turned it into some formalized attacks. The upper left-hand side are the attacks that I put in my book. The other side is the one Dr. James Whitaker put in his book. And you'll notice there's a lot of them, right? That's like tip of the iceberg number of attacks. And the bad guys have a lot more that we slowly learn about. But these are the kinds of things that people on your teams or people on the independent teams should be looking at. And I'm about on time, because I was told to be off at 10:15. But being an embedded rocket scientist, timing is very important. And I messed up at the conference because I saw the time and I finished up nice and early, and the poor announcer was thinking I'd go late. So I got like 3 minutes to do this. My wife and I and other people, Dr. Nishi, have been coming in here to Malaysia for help and collaboration, working at conferences, and also helping some of the education things get set up. And you've got really good education things going on, a really good program like here at the Institute that's very commendable, I think. You know, I think we have to work on people and processes, people certainly, and tools and technology. And I realize some of you are working on tools and maybe technology, but don't forget the people and the processes and tailoring of those processes. Out there is MSTB and organizations like that here in Malaysia, and the universities. And the universities here have to stay competitive. And I tell the students when I come here, I tell my college students when I have them, and the engineers that I used to manage, I was like, you're in a field where you constantly have to learn. You always have to be learning either formally or informally, or doing experiments on your own, or reading on the internet carefully. And then this all has to be supported by government and industry. I think Malaysia is doing a pretty good job on that. Such things as skill and training, certification. I've worked a little bit with online training. I think the younger generation that are addicted to those phones, that's how they're going to work. And we have to figure out how to train them on the phones much better. That's going to be my next effort when I stop coming to Malaysia. Okay, I'll keep coming to Malaysia too. And then finally AI. And I think the AI and the online training may end up going together a little bit on those things. And I think the hands-on part and the continuous learning, again, I emphasize that to you, but I emphasize it to all the students that are out there. I have another minute. So anyway, that's my view of the future. There's other issues. You know, this isn't the only set of, I'll call it opportunities and challenges. As I told some of you, John Hagar, my company's called Grand Software Testing. There's nothing grand about it. I just live in a place called Grand County, Colorado. Every business up there is grand something or another. And yes, the guy in the hat is a cowboy. That's me. I am a little bit of a cowboy, but I'm a high-tech cowboy. And that's maybe, and don't read anything to the fact that I'm wearing a black hat. I am a good, ethical hacker. I'm not a flat hat cowboy. And that's another picture of my smart house. And I'm done. My second wife here says it's time. So I don't know if you want questions or
Yeah.
just send Dr. Nishi there.
So, with all the work that's going on in IR 4.0,
Yeah.
I also developing standards for integration, to make it easier for things to talk to each other.
There are some things on integration, and not so much at the test level, although we do have some test related things there. 15.280, 12.207 talk to some integration things. Also, Francois, I think, is working on some stuff related to the artificial intelligence and integrating some things. I think Dr. Nishi is going to talk to some of that too. So the answer is yes. The thing about standards is they're not leading. They tend to be after we really know how to do something. So I hesitate to call them lagging, but the definition in my mind of a standard is something we really understand how to do. A lot of this stuff like integrating 4.0 and these big data and the AI stuff, and I think Dr. Nishi will talk a little bit more about this, we're still learning how to do that, which is both a little bit scary and challenging. And then some of these things we're just going and doing already and finding as we go. So maybe not the answer you wanted, but that's kind of the things we're at. So, anything else? Cool. Oh, you're in the back. Talk
Yes.
loud. I'm old. I got really
I will.
loud.
I will. I just want to ask a question related to standards, right? So, for IR 4.0, how do you see standards coming in? Because, currently for testing you have 29119, right? But when it comes to industry verticals, right? So perhaps for safety and security in the automobile industry, as compared to medical or aeronautics, do you believe that standards are going to be a key driver for testing?
Well, I hesitate to call them a key driver. I think they will be one of the things people should consider in there. We have some things that I think we're going to work on, in particularly working group 26, which is the one that does the 29119 standard. There's some things being worked on in some of the areas like automotive and AI. So I think that'll be informative, at least. It remains to be seen how quickly we're going to be able to put those things out and reach. We have to reach consensus. And as some of the folks here in the room will tell you, consensus in some of the working groups takes a little bit of time, and is easier said than done. So that's kind of on the process side of things. The other part that I think standards definitely help on is the actual, I'll call it product side. I don't work so much on that, but there are standards for like automotive and medical and things like that are already in place that I think will help. The automotive, I think, is progressing along nicely. I worry a little bit about like medical sometimes because they seem, I don't know if the word's more conservative, but I've talked to some of, at least in the US, some of the regulators, and they're like, we like what we do. But I'm like, but it's too slow and I'll call it old-fashioned. They go, we like what we do. I think other places like smart cars and maybe smart cities are progressing quicker. But that's kind of on the product side. And bringing those things together, it's not easy, unfortunately. And people like some of us here in this room, I only have so much time in my life.
Okay.
We'll hear for a while, so you can ask questions later, I think.